Let's continue with lesson activity number 11 and number 12 from lesson number 7. Lesson activity 11, solve using the quadratic formula. So we have a quadratic equation that we need to set equal to 0. So one of the possibilities is to subtract x from each side. And then subtract 1 from each side. So this equation is equivalent to 2x squared minus 4x minus 1 equals 0. Of course, you have another option here, which is to subtract 2x squared from each side, which would give you 0 equals negative 2x squared plus 4x plus 1. Both of these equations are equivalent, and it doesn't matter which of these you choose when you solve this using the quadratic formula. Let's just pick this first one right here. So 2x squared minus 4x minus 1 is 0. So our first job, once we set it equal to 0, is to identify the values for a, b, and c. So the coefficient for x squared is a, which is 2. Coefficient including the sign of the operation is the coefficient b, which is negative 4. And then our constant term, c, is negative 1. So let's take a look at this now. So we're going to solve an equation, and the solution will always have x equals. So we always want to make sure we begin a solution with x equals. X equals the opposite of b, which is the opposite of negative 4, plus or minus the square root of negative 4 squared minus 4 times a times c, all divided by 2a. Okay, a couple of things I want to point out here. I highly recommend that you use brackets here. And this is helpful particularly when this product here, this multiplication problem, the answer to that is negative. That way, this subtraction sign and the negative in front of the number here are clearly separated. That's often an area where students make mistakes. The other area I want to point out to you is this right here. Okay, because b is a negative number. And anytime you raise a negative number to a power, you must put that negative number in parentheses. Okay, the parentheses must be there. And the reason is this. Negative 4 squared equals negative 4 times negative 4, which is 16. The base here is negative 4. However, when you write this, even though at first glance you might think it's exactly the same thing, this says the following, negative 4 times 4, which is negative 16. Some people like to put a negative 1 there. So it's very important if b is a negative number that you put that in parentheses. Because if you were to write here dash 4 squared, and then when you simplified it, you wrote 16, that would be incorrect. 16 is correct, but dash 4 squared does not equal 16. Okay, let's continue. So this equals 4, the opposite of negative 4 is 4, plus or minus the square root of 16 minus a negative 8 all over 4. This is 4 plus or minus the square root of 16 plus 8 all over 4. Again, this is one area where I sometimes see a lot of errors is when you're subtracting a negative number. So this is 4 plus or minus the square root of 24 all over 4, which is 4 plus or minus. Now, to get the exact solution, we need to ask ourselves, can we simplify this radical? And the answer is yes, because the number 4 is a perfect square, and the number 4 divides into 24. So you can represent the square root of 24 as the square root of 4 times the square root of 6. And now you can simplify the square root of 4 to be 2. Square root of 6 stays as it is, all over 4. Now you see that 2 is a common factor to this term here, to this term here, which has a 2, and to 4. So there's a couple of ways you can think of this. One way is to pull out the common factor 2 in the numerator, and what you would have left is 2 plus or minus 2 square roots, not 2. 2 plus or minus the square root of 6 over 2 times 2. So there's your common factor of 2 on the top and bottom. That makes a factor of 1. So our final answer here, exact solutions, is 2 plus or minus the square root of 6 all over 2. So those are the two values for x. And as you remember in your My Math Lab homework, you have to write your solutions in a solution set. So the smaller number always goes first. That's 2 take away the square root of 6 over 2. And your larger number, 2 plus the square root of 6 all over 2, would be how you would write that solution set. On a quiz or a test, this, if you just put a circle around there, that's fine for me, with me. Okay? So that's number 11. Number 12, now we're in a totally different realm. We're going to borrow some of the strategies that we use with solving quadratic equations when we factor quadratic equations to help us with this next problem. So the next problem is what we call a polynomial problem. It's a cubic polynomial. A quadratic and a linear equation are also polynomial equations, and we call this cubic because the highest power you see on your variable x is 3 throughout the equation. It's the highest one you see. So let's take a look at how we go about solving polynomial equations. Well, right now, you don't have any method for solving an equation to the power of 3. We can solve an equation that has a power of 2, and we can solve an equation that has a power of 1, but we don't know how to solve an equation that has the power of 3. So we saw that when we were solving quadratic equations, if we could factor the left or right-hand side of our quadratic equation into two quantities, if we could multiply them, then we knew that to arrive at our answer, either A had to equal 0 or B had to equal 0. And notice we had two quantities here, and that tends to go along with the exponent 2. So if we want to extend that idea, is it possible to take this equation and factor it in such a way that we would have 3 factors that equal 0? And then we would use exactly the same idea to solve for x. We'd say, well, when does this equal 0? When does b equal 0? When does c equal 0? So if you recall, the very first type of factoring that you should always ask yourself about is there a greatest common factor throughout this expression? Well, the first thing you notice is that every single number here is even. So you know that you have a 2 common all the way across as a common factor. And then you say, is there an x common all the way across? And since every single term has at least one x, then you know 2x is your greatest common factor. So we put 2x out in front. This is like that big capital A. And now we put some parentheses. We set it equal to 0. Remember to always include your equal 0 here because you're solving an equation. So you want to see equal 0 all the way down. And now what I remind students about is that since you have 3 individual terms up here, you will have 3 individual terms inside your parentheses as well. So you can ask yourself, what would I have to multiply 2x by to get 2x cubed? And hopefully you can see just x squared, since 2x times x squared would give you 2x cubed. Similarly, what do you multiply 2x by to get 4x squared? And your answer is 2x squared, 2x. Notice I've just brought down the same exact sign. The sign of the operation here is subtraction. And then 2x times 15 will give me 30x. So now I have factored that first equation into two factors. Here's factor 1, and this whole thing is factor 2. Okay, but I really would like to see if I could factor this so that I would have 3 factors equal to 0. They would all be linear, and I could solve them really much quicker. So let's see if we can factor this expression. So over on the side here, I'll say x squared minus 2x minus 15. Can I factor this? Let's see. So I'm searching for factors of 15 that differ. I say differ because of that sign, by 2. And I don't care much about the fact that it's negative 2 right now. So on this, in my head, I know that the only factors of 15 are 15 and 1, and 5 and 3. But 15 and 1 differ by 14. 5 and 3 differ by 2. So I know I'm going to be using a 5 and a 3. So I'm really happy. I come back here. I set up my 2 parentheses. I put x in the first term. And I know it's going to be a 5 and a 3. And now this is when I say, oh, it's a negative 2x in the middle. So if I'm going to add 2 numbers, one negative and one positive, and I end up with more negatives, negative 2x, then my larger number carries the negative sign, and my smaller number will carry the plus sign, or subtraction and addition. Now it looks like A times B times C is 0. So I take each one of these factors and I set each one equal to 0. And each one of these equations are now linear equations that you have learned how to solve in previous classes. So when does 2x equal 0? When x equals 0. When does x minus 5 equal 0? Well, if you add 5 to both sides, it's when x is 5. And x plus 3 equals 0. Subtract 3 from both sides when x equals negative 3. So there are the 3 solutions to the cubic equation. And if you were writing this in my math lab, they want a solution set. So now you have 3 numbers. So your smallest number would go first, then your middle number, and then your largest number. Okay, that finishes off the lesson activities for lesson number 7. Let me know if you have any questions.